Hello, friends. How are you? I hope you are doing really good. So, in today's video, we are going to learn about pulley system. In the last video, we have seen the demo for the pulley. In today's video, we are going to see the concept and see how to solve the problems based on pulley. So, let's get started. Engineering Fundamentals, and I am Yugandhara Talele. Content of the videos are introduction, cables, its definition, some basics, problem on cables, then what are pulleys, some notes regarding how to solve the problems on pulley. What is mechanical advantage of pulley block and some problems on pulley. Pulley. Pulley is also known as sheave. A pulley is used to change the direction of the applied tensile force. So here this 100 Newton weight is to be lifted up with the help of this pulley. So you can see this is a pulley wheel and the rope is holding the weight and force is applied at this end. The force is also equivalent to 100 Newton and the distance to which it is lifted is also equivalent to the distance the rope is pulled. So here the direction of applied tensile force is change and this weight is lifted up. Mechanical advantage. A series of pulleys working together known as block and tackle can also provide mechanical advantage. So here in this picture you can see a series of pulleys are working together. These are the few examples of mechanical advantage of rope operated pulley. So here two pulleys are there in series, three pulleys, and here this is a fixed pulley and this is a movable pulley. Here two weights are there and in this example this M1 is supported and these two pulleys, pulley 1 and pulley 2, are acting in series. Notes. For wires passing over smooth pulley, tension is uniform. So here this is the pulley wheel and this rope is on this pulley. This pulley is fixed. So in this rope there is tension T and which is uniform throughout the rope. So this is how the free body diagram is drawn. And T, this T, 2T means these two T's and weight W acting vertically down. Notes again. Most simple problems disregard friction and assume that all ropes, that is fiber ropes, wire ropes, chains, belts, etc. are parallel. In such a case, the pulley advantage is equal to number of ropes coming to and going the load carrying pulleys. The diameter of pulleys are not factors in calculating pulley advantage. Fixed and free pulley. So what is this fixed and free pulley? In this picture on the left, this is a fixed pulley. Fixed pulley is fixed at this point and the rope is on the wheel. The load is applied at one end of the rope and force is being applied to the other end of the rope. So here the force is equivalent to the load. So this is fixed pulley. And real life example of fixed pulley is raising flag on the flagpole. Now for F ideal for fixed sheave is W. That is I told the force equivalent to lift this load is equivalent to the load. You got that? Okay. Now we will see movable pulley. In this picture, you can see the rope is fixed at this point and this pulley wheel is moving on this rope. Load is applied at the pulley and input force is being applied at other end of the rope. So in this case, F ideal is equal to W by 2 because these two tension in the rope is lifting this load. So it is W by 2. Ordinary pulley block or N sheaves. When two or more pulleys are used together for extra strength, this is known as sheave block or pulley block. So to calculate F ideal for N sheave, it is W by N. So W is the load or weight we want to lift and N is the number of pulleys or sheaves. So in this case, it will be W by 2. In this case, it will be W by 3, like this. Differential pulley block. So it consists of two fixed pulleys of unequal radii that are attached to each other and rotate together as a single pulley bearing the load, and the endless rope here is looped around the pulleys. To avoid slippage, the rope is being replaced by the chain and the connected pulleys by sprockets. So in this case, to calculate F ideal for fixed sheave, it is W by 2 multiplied by 1 minus the ratio of the diameter of the smallest pulley to the diameter of the large pulley. Two bodies connected through string such that one lies on smooth horizontal surface. So here in this picture you can see this is the smooth horizontal surface and M1 and M2 are connected with the string. That string passes over this pulley. So there are three cases. In the first case, if pulley is frictionless, then tension T1 for this part of the string and tension T2 for this part of the string will be equal. T1 will be equal to T2. And A1, that is motion of this block, the distance traveled by this block, A1 is equal to A2. Acceleration of this M1 will be equal to acceleration of A2. If pulley is not frictionless, there is some friction this rope has to resist, then the T1 in this part of the string will not be equal to T2, the tension in this part of the string. And acceleration A1 for M1 will not be equal to acceleration A2 for this M2 if the pulley is not frictionless. And always remember the direction of motion. M1 will move in the horizontal direction and M2 will move in downward direction. Take it as a positive. And we have drawn the free body diagram for M1 here. So M1 is having its weight, it's W1, then tension here in the string, that is T, and the normal force, that is by this surface. And for M2, the free body diagram is its weight W, and here it is attached to the string, so tension T. So remember this for solving problems. Problems on pulleys. So problem 1. In this case, these are pulleys acting in series, lifting this 10 kg weight. So we have to calculate F ideal for this series pulley, for this pulleys in series. So it will be W by N. So it will be 100, this 100 Newton, kg, 10 kg converted to Newton, 100 Newton divided by 4. It will be 25 Newton. Now similarly, for this problem, it will be W by N. Can you solve that? Now we will calculate F ideal for this differential pulley block, and in that F ideal for this fixed sheave or pulley. So it is, W by 2 into 1 minus D upon capital D. So here the diameter of this bigger pulley is 40 centimeter and the diameter of this smaller pulley is 20 centimeter. So we inserted that here and we got it as 25 Newton.